Hello and welcome everyone. This is Noah, and in this video we're going to learn how to simplify complex rational functions. The instructions for us here are exactly that. Rational expressions. Let's start with what is a complex rational expression. It's when you just have a little fraction inside of a bigger fraction. So here, let me point out, this is my big fraction bar, and we have this little fraction over a little fraction. So there's a couple of different ways that we can do it. And I'm going to show both of them, and we'll kind of decide which one makes more sense. Sometimes one of the methods is easier than the other. How do I want to say that? Sometimes it's easier to do like a flip and multiply thing, but usually it's going to be easier to do the second method that I show you. So hang on here for that. This is essentially saying that we have 6a minus 6 over a divided by, that's that big fraction bar there, divided by a minus 5 over a. So what we can do is we can change the division to multiplication and then flip the second fraction. And then from this point we would look at reduction, so that a's can cancel to 1's, top and bottom. And then when I multiply, I'll get 6a minus 6 over a minus 5. And then we can factor 6 out of the top, but it's not going to do anything for us. It'll be 6 times a minus 1 over a minus 5, and nothing cancels there. So that would be it. That would be our final answer, and this would be either or here. And this is totally fine. We can totally do it this way. But I'm going to show you another method. I'm going to rewrite the problem 6a minus 6 over a all over a minus 5 over a. And what I'm going to do is I'm going to take advantage of the fact that I can multiply by 1. If I multiply by a on top of the big fraction and a on the bottom of the little fraction, I'll note that this is meaning like a over 1 here. Then I'm going to zoom in on this is multiplication, right? So these a's can cancel there, and they can cancel here. And when that happens, I'm left with, on top of the big fraction, just the 6a minus 6, and on the bottom, we're left with just the a minus 5. And there we are. We're already at our final step. So it only took us just that one bit of work to get. So this is a new technique. I know it's not the flip and multiply that you're used to, but math is about, I mean, as you take any class, you're learning new things. So I want you to learn this new technique. I don't want you to leave it behind, even though there are ways of getting through these problems without it. I want you to go ahead and take the time to figure this out, make sure you're using it and getting comfortable with it, because as you do, it's really handy. It's going to make our lives a lot easier as we go through these problems. So let's take a look at this second complex rational expression that we have here. Part B, we have 2 plus 1 over p all over p plus 10. So I'm just going to note the denominator right here, and that's what I want to multiply. For the big fraction, I want to multiply by a p on top and on bottom. Now, I have to be careful because the numerator has an implied parentheses around it, as does the denominator. So when we do this, this p is going to have to distribute to both of these. So really what we have is 2 plus 1 over p times p, and this distributes to both, so this will be 2p plus 1 over p times p, And then in that second fraction, the p's cancel, but that p didn't cancel when we multiplied it by the 2. So be careful as we do this. These cancel to a 1. So this will be 2p plus 1 on top. On the bottom, we'll leave it factored as p plus 10 times p. Isn't that kind of nice? So if I just take that little denominator and multiply it on top and bottom of the big fraction, multiply the little denominator across the top and bottom of the big fraction. Right? And we're allowed to do that because this is 1, right? It's a special version of 1, so I haven't changed the value in any way by doing this. And that's it. The top doesn't factor here, right? And so I'm not going to be able to reduce it all, and that's our final answer. All right, these can get a little bit more complicated. Let's see what happens in some of these next ones. Here I've got plus 1 over b minus 6 all over, big fraction bar there, 1 over b minus 6 minus 1 over 6. So I need to change the directions a little bit because we've got the b minus 6 and a b minus 6, and I also have a 6 here. So I want to cancel all of those to get rid of the little denominators. So we're going to say multiply the top and bottom of the big fraction by the common denominator of the little fractions. So the common denominator we need to recognize as b minus 6 times 6 for the little denominators. So we're going to do that b minus 6 times 6. We're going to multiply that top and bottom. And so let's look at the top. What we really have is 8 plus 1 over b minus 6 times now b minus 6 times 6. And so we're going to take all of this and distribute it across that addition there. So we're going to get 8 times 6 is 48 times b minus 6 plus, in the second one we have 1 over b minus 6 times b minus 6 times 6. And so this is going to be, I'm just going to write it as 48 times b minus 6 plus just a 6 because the b minus 6's cancel in the second one. So I'm going to write that on top. Keep my big fraction bar here. On top we now have 48 times b minus 6 plus 6. On the bottom, we had a 1 over b minus 6 minus 1 over 6. And we want to distribute b minus 6 times 6 across this. So when we do that, I'm going to have 1 over b minus 6 times b minus 6 times 6 minus 1/6 times b minus 6 times 6. In the first one, the b minus 6's will cancel. In the second one, the 6's will cancel. And what we'll be left with is a 6 minus, in parentheses still, b minus 6. Now this might seem like a lot over here on the left, and so what we want to do is get better at doing that quicker and in our heads more. And it is possible, and I am going to give us some tips and techniques for how we can do that arithmetic or that algebra in our heads. So let's go ahead and simplify this, and then I'll go back and do that one more time without that side work. So on top I'm going to have 48b minus 6 times 48. Oh, that's fun. 6 times 48. 6 times 40 is 240. 6 times 8 is 48. So this is 288. We solve that plus 6 over 6 minus b plus 6, because that negative has to distribute there. Then on top we'll have 48b minus 282 after adding the 6 to the negative 288. On the bottom we'll have negative b plus 12. And I think we might be able to factor the top, but I don't think we need to worry about it. Because 6 is going to go into that, both of those. Let's not sweat that. Let's just leave that as is. Okay, so I want to go back to this top step and discuss how we could get from here to here without any side work. So I'm thinking the b minus 6 and the 6, both of those to the 8. So that's just going to be the 48 times b minus 6 right there. And then in the second one, and only in the second one, do the b minus 6's cancel and leave us with the 6. So see how we can do that without the side work there? We need to be careful and make sure we're not messing it up at all, but we can see that. In the denominator, we are we're taking, again, the b minus 6 times 6, and we're going to distribute it to that first term. And here the b minus 6's cancel and leave us with just the 6. In the second term, when this goes to the minus comes down, and then the 6's cancel in that second term, leaving us with just the b minus 6 that we see there. So as we do this, we can start seeing how to get through it quicker so that we don't have to also do all this work off to the left, which is obvious. It's a lot of writing, and the goal is not to make you do all of that writing, it's so that you can see how to do this without that writing. But as we're learning, it's nice to see exactly how those steps are playing out. So this is all just scratch work over here. Let's try this next problem without that scratch work off to the side. Here we have 1 over u plus 1 plus 5 over u minus 1 all over, there's our big fraction bar, 10 minus 1 over u minus 1. So my common denominator is going to be u plus 1 times u minus 1. We'll multiply that top and bottom, u plus 1 times u minus 1, against the big fraction. So on top, we'll take that and distribute it to the first term. When we do that, the u plus 1's will cancel, and we'll be left with a u minus 1. Then we're going to start over. We're going to distribute the entire thing, u plus 1 times u minus 1. We're going to distribute this now, to this second term. When we do that, the u minus 1's cancel. We'll be left with plus 5 times u plus 1. Okay. Now on the bottom, we're going to take the u plus 1, u minus 1, and distribute it first to the 10. That's not going to simplify at all. There's no denominator with that 10, so nothing will cancel. So we'll just write it all out. 10 times u plus 1 times u minus 1. Minus, now I'm going to take the whole u plus 1, u minus 1, the whole thing, and multiply it by the second term. And the u minus 1s will cancel here, and we'll have 1 times u plus 1. Stay this fraction bar out. And now we can just go ahead and combine like terms, simplify, all that. So on top, we'll have u, we'll have u minus 1 plus 5u plus 5. On the denominator, I'll have 10 times u squared minus 1, multiplying the u plus 1, u minus 1 together. And then I'll have minus u minus 1 after distributing the negative 1 across to that second grouping. I'm going to continue forward here. U plus 5u on top is 6u, and then we have a minus 1 plus 5 is plus 4. On the bottom, we're going to have a 10u squared minus 10 minus u minus 1. And then this will be equal to 6u plus 4 over 10u squared minus u minus 11. And I don't think that's going to factor at all, so we're going to call that good right there. Like, you might try and factor that denominator, but I don't think we're going to get anywhere with that, so let's not worry about it. Reading this common denominator across to both of them, right? The whole thing goes to both. So just because you cancel in one of them doesn't mean that the whole thing doesn't go to the second one as well. All right, let's do one more. This one's kind of our that we have for these examples. We're going to start, in this case, by factoring that first fraction. So let me just read this off. We have 6x over x squared minus 25 minus 5. All over, big fraction bar here, 2 over x plus 5 plus 1 over x minus 5. We'll start by just factoring that x squared minus 25 as x plus 5 times x minus 5. And we see that that's going to be our common denominator amongst all of the little fractions inside this big fraction. So I have 6x over x plus 5, x minus 5, all minus 5, all over 2 over x plus 5 plus 1 over x minus 5. And I want to multiply the top of the big fraction by x plus 5, x minus 5, and the bottom of that big fraction by x plus 5 times x minus 5. So we'll go ahead and take the x plus 5, x minus 5, and distribute it across the subtraction on top. When it goes to the first, both the x plus 5 and x minus 5 cancel, leaving us with a 6x. In the second one, though, we have a minus 5 times all of that, and there's nothing to cancel either, so both of them will be brought over. So we have 6x minus 5 times x plus 5 times x minus 5. Then on the bottom, we want to distribute the x plus 5 times x minus 5 first to the 2 times x, 2 over x plus 5. Here the 2 will come down, the x plus 5s will cancel, but we'll be left with the x minus 5. Then we have plus, and this is now going to go to the second term. The whole thing goes to the second term. The 1 from the top will come down, the x minus 5s will cancel, but the x plus 5 will be left over. Great. Now we can go ahead and start looking distributing things out, combining like terms, all of that. So on top, I'm going to have now 6x minus 5 times the x plus 5, x minus 5 multiplied together as x squared minus 25. Over on the bottom, we're going to have 2x minus 10 plus x plus 5 after distributing there. And we'll continue on. We'll distribute the 5 across, so 6x minus 5x squared. And then minus 5 times minus 25 will be a plus 125. All over 3x minus 5 on the bottom. And let's just rearrange the top. Negative 5x squared plus 6x plus 125 all over 3x minus 5. Let's go ahead and just for trying it, let's try and see if we can't factor that numerator. I don't think it's going to work. I'm going to take negative 5x squared plus 6x plus 125, and I'm just going to try. If I had a negative 5x and then an x, and then the 125, good factor is 1 and 125. That seems unlikely to get a 6, right? And then we could have a 5 and a 25. And that's really it. So I could do like 5 here and a 25 here, but that's not going to add up to 6 in any way, even when we distribute that, right? That would add up to like 0 if they were both positive. And if this was a 5 and this was a 25, that would be like negative 75 plus 5 would be definitely not a 6. So this is prime, does not factor. So we are done with this problem. And even like, and the other thing to note here is even if it did factor, it wouldn't factor with a 3 in the front. So even if it factored, it wouldn't reduce with anything. All right, I hope that those examples helped you get more comfortable with this technique, right? So this is the technique that you want to get comfortable with. It really is handy. It takes a little getting used to, but give it a shot and try it. And once it clicks, it's really nice and handy to be used.